Yo, so today I'm going to give you a little bit of a rundown on how I fitted my aftermarket ECU, because I've been getting quite a lot of questions based off of my social media posts and videos. First of all, this is my ECU. It's a Megasquirt MS2 V3 with the extra code, and it came from Extra EFI. If you just Google that, you'll find it. I've had a look this morning and the ECU is about £450 these days. It's got a plug like you can see there, and it comes with approximately about 1 metre of wiring, which you have to splice into the Micra loom. Go into that a little bit more in a minute. And then for the app that I'm using on my phone, I've got this Bluetooth dongle that also came from Extra EFI, and it literally just plugs straight into this COM port on the end. And you download Shadow Dash and hook it up, and there is another MS Droid, I think it's called. There's another app, but yeah, I'm happy with Shadow Dash, so I'm just using that. So from there, you also will need a fuse box. Now you're gonna have to excuse this because I never actually finished it all up properly, but there's my fuse box hidden in behind, and that fuse box is fed by this there's a little fuse in there. That fuse is connected straight to my battery. You don't need to use that. As I said in my last video, you can use the big thick green wire that usually powers up the coil on a K10, but I'm trying to make this specific to K11s as well, this video. So I'm using a K11 engine loom. This here is literally just that's a headlight relay box for a K10 that's usually in the engine bay, and I relocated it. So is all of this stuff up here. It's because the loom used to go through the bulkhead somewhere, and now it goes out underneath the wing to hide it all. So this is from the relay, and it goes off and it connects to the fuse box that I just showed you underneath there. So that's how I get all my power for my ECU, or for all the relays, sorry. So I've got relays hidden underneath the dash as well for the fuel pump and for the ECU. Now the Megasquirt diagrams are pretty decent. They're quite easy to follow, so you just need to, when you buy your ECU, you will get a diagram, so you just follow the diagram. And I'm colourblind personally, so I've just used the diagrams and a multimeter, and I don't go by any colours or anything. I literally just trace everything with a multimeter. Now this injector loom is actually from an MX-5, purely because I'm using top feed injectors and they have different plugs on them to standard CG13 Micra, and I think they might be different to CGA as well. I think I've never had a CGA, I've just got a CGA top feed rail for this throttle body setup, but originally I had a CGA intake modified with an SR20 throttle body on it. Now I will have a look in a bit and see if I can find that inlet manifold so I can show you how I put an SR20 throttle body on. So one of the main things is crank position sensor. You're going to need a crank position sensor because there isn't currently a decoder on the Megasquirt for the standard Dizzy, so I've just removed the Dizzy and blanked it off. So what I'll do is I'll quickly give you a rundown on how I managed to put a proper crank trigger wheel onto this engine. It involves getting down on the floor and going underneath the car. And I'm going to have to turn my light on, I think. So as you can see, I've got an oil leak. That's the rocker cover, by the way. Yeah, I've got a crank trigger sensor here, which is a Bosch one that you can buy off of eBay. If you put in Cosworth crank position sensor. In fact, it's not. It's a Magneti Marinelli, and it plugs. It's got like a shielded cable that runs all the way underneath, goes up there somewhere, and then the plug is just up there. Look. So I also bought a plug as well off of eBay, and then I bought a length of shielded cable off of eBay, because you need to run shielded cable so it doesn't get electrical noise, and I run the shielded cable all the way back to the ECU plug, so I highly recommend doing that. Now for the crank trigger itself, the actual teeth, it's hard to see here, but they're actually cut into the bottom pulley itself. Now I've got a bottom pulley on the bench. We'll go and have a look at that right now. So this is the pulley I'm using. It's the CGA10. It's the steel one rather than the casted one, and it's hasn't got all the rubber stuff in it, so it's not harmonically balanced, but it is the lightest weight one, and it's the easiest one to work with for this. So as you can see, this grey mark, that is 0 degrees, it's top dead center. The engine normally runs at idle, it would be set to 15 degrees before top dead. Now what you need to do, well, I've got a 36 teeth with one missing tooth on the car, and the missing tooth needs to be 90 degrees before top dead center, so that's 9 teeth. So this is where my missing tooth is, and what that does is, because if you have your missing tooth here but you set your timing up to here, then the ECU, it can't do that. It'll always be out of phase, it'll be behind itself. So what you do is you have your missing tooth 90 degrees before top dead, and then that gives the ECU 90 degrees to make its decision on when it's either going to fire, where it fires the coils. So basically it gives it, 75 degrees of time to fire the sparks at the right time. So that's just that's quite simple really. You basically set it at top dead center, with either this mark, although the marks are practically missing off of mine, so it's almost a bit of a guess. So what I did was I set it to top dead center with a screwdriver in spark plug hole, and then I marked this mark on my car with a little dash of paint, and I also could kind of see the marks on the edge of the teeth. When I got the teeth machined in by the engineering company, I asked them to try and give me some indication where this point was, so I could mark it with a bit of Tip-X. So yeah, I get it on top dead center with this mark, and then I made my bracket and my crank sensor so it lined up perfectly with the leading edge of the missing tooth. And then when you actually fire the car up for the first time, you can set the ECU so that it's locked at, say, 15 degrees, and it's not advancing at all. So you lock it, get your timing light, and then you can adjust in the ECU forward and back X amount of degrees you need to get it to bang on 15 degrees. I hope that makes sense. It's kind of confusing, but I'm probably explaining it better than the Megasquirt manuals, but it is all in the manuals, and I am always here to help if you need a little bit more guidance on that. Now the next thing is coils. Because you've removed the Dizzy and the coil pack is in the Micra Dizzy, I'm actually using a MX5 coil, which is tucked in down, let's turn the light on a minute, it's not really visible, but yeah, it's tucked in down here. Oh, I can't get a focus. There we go. That's where I've hidden it, but I did make the brackets so that it did bolt on the end, but I wanted to hide it away. So that's pretty simple really. MX5 coil. Because I've got a lot of MX5 stuff, I ended up using the MX5 coil pack loom because it's got this plug on it already. It's already got a coolant temperature sensor plug, and then I just bought a Bosch temperature sensor purely because I already had all the figures and that to plug into the Megasquirt, so that it knows the resistance curve. I mean, I'm probably going a bit in depth and confusing people a bit here, but we'll just brush past that. That's something that you get into when you're actually setting it up. It's basically so the ECU knows what temperature the engine's at and can set the fueling accordingly. Now, this is the shielded cable I'm using. All of this is unbundled at the moment, so I can show all of this to you. But yeah, this is a shielded cable that comes from the ECU and down to the crank sensor. Actually, I'm going to leave that up there so I can cable tie it in a minute. And then the next little thing is TPS. I mean, it doesn't matter what TPS you use, you just use your Micra or whatever engine you're using, actually, the corresponding TPS to that engine. Make sure you've got the right wiring diagram for the TPS, and then you just wire up from the Megasquirt to the TPS using the Megasquirt wiring diagram. It'll have an earth, it'll have a 5-volt feed, and then it'll have a 5-volt signal wire going back to the ECU. And you know you've got it right straight away, because when you calibrate the TPS in the ECU on your laptop, it will start at a lower number, and when you put your foot on the throttle, it will go to a higher number, and you just calibrate it. It's quite self-explanatory, and I actually did it in 2 videos ago, I believe. So next on the list is intake temperature sensor. The Micra doesn't have one because it uses a MAF, and it's all in the airflow meter that's built into the throttle body. But down here, if I can zoom in a bit, you can see I've got a boss welded on the bottom of the intake, and I've got a intake temperature sensor in there, and that basically is the same as the coolant sensor. It's just it's an open element instead of a closed element, so it works a bit quicker with fluctuations in intake temperature. Now that's just the same scenario. In fact, I think the graph, the temperature graph, the resistance graph is the same as the coolant sensor. So next on the list, we've got lambda sensor. Now my lambda sensor is a wideband, and you can see it right there, but you can use a narrow band, but it's kind of pointless. I mean, if you get it tuned on a rolling road, you don't really need to worry about having a lambda sensor, but it's always handy. I got a wideband, just makes life a lot safer and a lot easier, and I can tune it myself on the road, and I can use the exhaust gas oxygen correction in the ECU. I'll go quickly in the car a minute and I'll show you. I've also uncable tied all of this stuff as well, so I can show you. It's just tucked up under the dash so I could drive to my workshop this morning so I could do some work. So this is the box that controls it all. It's a PLX devices wideband, and it's got a shielded cable that goes to the ECU. It's got a power cable and an ignition on and off, and that's about it basically. I mean, that's pretty self-explanatory as well. You just use the wiring diagram that comes with your wideband, and also use the Megasquirt diagram, and it's quite easy to figure out, and it's all in the Tuner Studio software for Megasquirt to configure this wideband to the ECU. Now what's next? I have written myself a little list so I don't forget stuff. So we've done the trigger crank sensor, we've done trigger wheel, we've done coolant and intake temp, we've done TPS. we've done the coil pack, done the Lambda, fuse box. Yeah, the ECU relay and fuel pump relay, they kind of work separately. So basically, when you turn the engine on, I'll just switch the ignition on so you can hear. Probably can't hear because now you can probably hear the relays work, fire up and then click back off, and you might have heard the fuel pump priming. That's basically, it primes for 5 seconds, and if it doesn't sense that the engine's turning over via the crank sensor, it will switch back off again. It's just a safety feature so that if you have a crash and the engine switches off but your ignition is still turned on, it doesn't keep throwing fuel at the engine, because you could have severed a fuel line, and then that's obviously dangerous. So the last real thing is injectors. You're probably best off, if you know the size of your injectors, just using what you've got with the engine. I personally am using Primera Reds just because that's what I've always used, and I did originally run this on Megasquirt with the standard intake with an SR20 throttle body, but that's kind of irrelevant. It doesn't matter what you're using for throttle bodies, but I can give you a quick rundown on how I fitted these throttle bodies to this engine. They are R6 throttle bodies from a 2018 model, I believe, and they were fly-by-wire. We had to do a little bit of modification. My friend Julian from Proform down in Plymouth, he actually made the inlet manifold for me. I supplied him with the tubing, and this part is a CGA manifold. I cut it off. This is so that I could, I had the flange and my injectors and my rail would fit, and I supplied him with the tube and the throttle bodies, and he made this manifold, which is absolutely stunning. But we wanted to get them fitted in on the car one day, and we just did it quite quickly, and it ended up the throttle, the cable stop and cable linkage setup that we came up with at the time was just, it was not suitable really. It was like an on-off switch and the pedal was too heavy. So I've since modified, and I've put this cable hanger on, which is quite upsetting because my welding is not as good as Julian's welding, obviously. And I put this quadrant from a MX5 on the end of the spindle, and normally, I don't know if you can see it, I don't think we're going to be able to see it, but yeah, right underneath there's another little quadrant. It's like half the size, and that's what we were using, and there was like a bracket hanging down from there with the cable on. Now the bracket was hard to get to, and it came loose all the time. The bolts were just not adequate, and I don't think we used any locking washers and or lock tight, any sort of thread locker, so they just came loose all the time. And since I've put this on the end of the spindle myself, and I've put this hanger on, it's actually like superb now. Couldn't fault it, it's perfect, absolutely love it. But the manifold is stunning and it works absolutely perfect, and I'm sure if you needed anything, you can look up Proform on Instagram and speak to Julian, and I'm sure he'll sort you out. Now I've also got, like, people are going to want to know about my launch control setup, and originally I put a button up here. I wanted it on the handbrake, but I couldn't get it to work off the handbrake, so I put this button up here, and I was going to run a curly cable, but the curly cable kept getting caught up on everything. So what I ended up doing was putting a clutch switch. So I took the bolt out, the stop, the pedal position, basically stop. I took that bolt out, and it's the same thread as a brake switch, which is there. So I got another brake switch, and I screwed that into there, and it's just wired up. Got an earth there, and then it just goes to a pin on the ECU. Now when you buy your ECU, you have to specify that you want launch. I basically didn't. So me and my friend, we looked at the diagrams, the schematics, and we actually added that in ourselves. Now there is a little bit more I could probably show you if I got a standard loom. What I might do is make another video showing you how to hook up a standard loom, and I'll also get the inlet manifold out, and I might put that in the end of the video that I'd converted for an SR20 throttle body, just so I can show you guys that. But if there's any more questions or anything you need to know about this, it will be worth like firing me over some comments, and I can make another video. Can I answer everyone's questions in another video maybe? And in the future, I've actually got 2 people that have asked me to put Arduinos into their Micras. Well, the Speedduino ECU, which is a much cheaper option, and I can't see it being much different to fit, to be honest. So that is probably something that I'll be doing in the future, and I'll definitely make a video, and I'll try and make it a bit more step by step and show you how I actually did all the wiring. But yeah, that's going to be it for this one. I will probably be back in 2 seconds with another manifold so you can see that. But I hope this is of some help to people, and we'll catch you soon. Right, this is the SR20 throttle body conversion. So I made an adapter plate which bolts onto the manifold, and then 2 of the bolts actually line up with the SR20 throttle body, and then the other 2 are just drilled into the plate with the correct length bolts. TPS just plugs straight in, and then this in the back was where I drilled and tapped to put in the intake air temperature sensor. The only problem with doing it here is you get a bit of heat soak from the engine, but I never really had a problem with it. This is actually a top feed rail, but you could do this, I think there's 2 different styles of throttle body, but you can pretty much do this with any. And then the only other thing you've got to do is you've got to go in the die grinder in there, and you've got to port it a little bit, which I can't really see if turning the light on will help. Can't really see, but I ported it inside so that there are no obstructions. It's just 60mm. Well, this is 60mm on the outside, but it's about 50mm in there, 50mm straight in, which is actually the same size inside diameter as the CGA mass airflow meter that's on the top of the throttle body. I have actually got a throttle body at home, SR20 throttle body, which has got it's got a CGA MAF welded to the top of it, which I can actually insert a couple of pictures at the end of this video, although I won't because it's irrelevant to this. I'll put it in another video. I've got another video with a little bit more explanation on the 16 valve conversion wiring using the Nissan pre-nats loom, so I will put those pictures into that video. Anyway, that's enough for this video. Any more questions? I can probably look into getting these adapter plates made if people are interested. Just hit me up in the comments or follow me on Instagram. Is probably the most reliable way, because sometimes I don't see the comments. YouTube's a bit weird with comments for some reason, even though I've got an app just for the comments and the analytics. But yeah, I seem to miss comments quite often and don't get back to people until it's a little bit late. So just probably follow me on Instagram, dory.professor, and hit me up if you need anything. Cheers!